So this wall here is going to be the one wall that's going to be duplicated all over this building. It's going to become the ground, the ceiling. It's going to be everything. And it's going to have to be pre-fractured in order for that to even be remotely useful to us. So here we go. If we wanted to fracture this into 100 different pieces, we'll need to make 100 points and feed that into a Voronoi fracture. And the Voronoi fracture takes the original geometry in the first input and the points into the second. As it stands, though, we are scattering on the surface. The surface of this geometry. And that's, for a thin piece like this, that's fine. But remember, if this was much deeper, well, now the points are just only on, we have this hollow shape now. And now the points are only on the surface. And that's not so great. What we want to do is create a ISO offset. The ISO offset, you remember from last lesson, is going to create a volume. And the volume will allow us to scatter points into it. This ISO offset with only 10 divisions doesn't really represent that skinny, sharp piece of geometry very well. So we'll want to actually take this and increase it quite a bit. Maybe like something like 70 or let's give it a little bit more. So boom, 80 looks good. It's nice and sharp. It looks like our original geometry. And now our scatter is in it. There are points that are not on the surface. They're all over the place. And so we'll get nicer pieces from that. I'll turn on visualize here so we can see it. And there we go. We have 100 pieces now. And again, when we pack this and then copy it all over the place, it will still never really take up much more memory than these original 100 pieces, because everything else in the building is just going to point back to these originals. So I have the color here. I'm actually going to go ahead and say, let's have this here, this attribute delete, to kill the color we just made. As you can see, color was a primitive attribute, and I just killed it. And I'll say kill viz. This will just be a little handy thing later that I've found is nice to keep around. Sometimes it'll be annoying to see the colors, and sometimes I'll want to see the colors. So instead of having to go back in here and finding this checkbox, now I can just press this one thing here. I mean, not saving us that much time, but when you have enough little time savers, it adds up. So we're going to want to name this now. And I like using these wranglers a lot, where we get to type and do exactly what we want to do. I'll call it name them. It's true that there is already primitive names on these pieces, and you can find them here under the primitive name attributes. And as we would expect, it does go from piece 99 to piece 0 for 100 pieces. But later on, we won't be able to rely on that, because I'm going to end up subfracturing some of these pieces, and the names we're going to get duplicate names and stuff. So I'm just going to go ahead preemptively and say, hey, let's name them something based on their if it's a unique piece or not. I'll use our old friend connectivity. Connectivity is a SOP that will essentially look at the topology of our geometry and say assign a unique class attribute, as you'll see here, from 0 to 99. Now these numbers aren't based off of the name. It has determined that each of these pieces is a unique island, not connected to any other island piece. So what do I mean by that? If I put an exploded view down here, just kind of as a spur off to the side, and I turn it on, it's doing that. Even if I delete piece name, we can have it now say, hey, piece attribute class. And you can see that it still holds up. It's showing us that these pieces are not connected to any other island. Pretty cool. So with that attribute, essentially what it comes down to, we can use that integer to name our pieces in the future. So no matter what breaking and smashing we end up doing up here, we can have 100 Voronois in a row. They could even all be misnamed. But at this point, we will determine who is actually an island piece. What is a self-contained piece? Name it based off of that class attribute. And to do that, we'll say string type attribute, so S @ The @ sign means create this attribute if it does not exist, or read it if it does. So s@ name, in this case, it's on the left side of an equal sign anyway, so it's going to be assigned to. It won't read it. It'll just create the attribute now if it doesn't exist, or it'll assign it to the existing attribute if it does. We'll say the primitive, because we're in the primitive wrangler, the primitive string type attribute name is going to be equal to sprintf is an old like C style function where we can do some like kind of text munging where we can just write text-based things. So it's mad at me because I didn't finish it. So I'll say something like piece %s %d. That %d is this thing here is a kind of a little placeholder that will be changed later based on whatever the next argument I put here is. So if I put @class, it's going to replace this with this. Always put a semicolon at the end, and voila, we're done. You can see it's back, it's not mad at me anymore. I'll go to geometry spreadsheet, and we can see under the primitives that the piece name is there. I'm going to press P down here for a moment to get another little parameter spreadsheet thing, or a little parameter window. If I typed anything in here, AA piece, you can see it says AA piece. If I said instead of class, replace it with some arbitrary number 5, you'll see now they're all piece 5. I could use a built-in primitive like primnum, which is the current primitive number that we're on, which is this number here. So you can see the 15 is being used, 885 is being used. But anyway, we don't need any of that. We want to use class. And if and when we ever change how many pieces there are up here, this will accurately, these two together, will accurately name everything for us. Great. So with that done, I'm going to bring this back over here. Now we actually need to pack this stuff up. Create an assemble SOP. The assemble SOP, we already made a name attribute, so we can turn off that. We don't want it to create a name attribute, but we do want it to create packed geometry. If I middle click now, you'll see we have 100 packed fragments. So now, if I try to select these things, they are all individual. They're just 1 point each and 1 primitive each. So the primitive is contains 1 point, as opposed to here, where we still had hundreds of polygons and over 1,000 points. Now, if I were to, let's say, grab one of these, or I pressed S4 to go into primitive selection mode, I can click any of these. Each piece now is an entire primitive thing. I can just tab transform in there. It's selected the primitive, and now I can rotate it just like it's a piece that has its own transform. I can move it around, or I can delete it even, and it will delete that same thing that this was working on, primitive 53. So now we're working on it kind of at a piece level, as opposed to when we were here, we were working on things at a per face level where it's deforming the thing. Okay, of course we don't want to delete it or move or anything yet. We want to keep this just like this, because this is going to be our brave volunteers to comprise the rest of our building. Cool. So now in the next chapter, we will actually build the building up.